Hi, this video will be on when we are allowed to use a normal distribution or a normal model to approximate a binomial model. Okay, so let's first start off and get the setup of the problem. They're saying 10% of men are bald, so the probability that somebody is bald is 0.1. So the probability they're not bald would be 0.9. Okay, so it's saying what's the probability that fewer than 100 in a random sample of 118 are bald? So X is the number bald out of 818. Okay, so X is a random variable. Now, is it a binomial? Is it a binomial? So every person represents a trial. Okay, we will have 818 trials. Okay, and each one is either bald or he's not bald or he's not bald. Okay, so they tell us that if 10% of men are bald, so then we have to assume that every person is independent of each other. 818 is a finite number. The probability of every single person being bald is 0.1. So this is a binomial. This is a binomial. Okay, so now the question is, does the binomial approximate a normal? Okay, so to do that, we have to say, well, out of 818, how many do we expect? How many do we expect? The question mark is how many do we expect? So, because the expected successes and failures have to be greater than or equal than 10. Okay, so to find that out is we just take, it's just n times p. It's n times p and n times 1 minus p. This is the expected value. So I take 818 and I times that by times the probability of success, which is 0.1, and I get 81. So you expect 81.8, so that's greater than 10. Check, we're good. Okay, so that's going to be the remaining people. It's the remaining people. So you could do it two ways. You could do 818 minus this, or you could do 818 times the complement of 0.1, which is 0.9. 90% of 818. We get 736.2. That's definitely greater than 10. Okay, now the next condition is that these 818 are less than, okay, so the sample equals 818. So the population is all males. Okay, so 818 is definitely less than 10% of the population. This is a way that we prove independence. Okay, to make sure our sample is independent. And if you haven't, watch that video on that, which should be before this video. Okay. All right, so what does this mean? This means we are okay to use a normal model. Okay, so when you're doing this, make sure you write this, because you're saying you know what you're doing here. If this is true and this is true, then that means this is true. Okay, so what is the mean? What is the mean of our binomial? Okay, and what is the standard deviation of our binomial? So to solve this problem, we have to know mu of x and have to know the standard deviation of x. So the average of x is just how many men that are bald that we expect. How many bald men do we expect? So we found that already. That's 81. I'll write the formula again, just in case. Okay. The reason that we need this is because I'm going to be working on this normal model now. Okay. So I'm going to need these two things. So this is NP, which is 81.8. 81.8. So this is 81.8. And this is the square root of NP. Just going to fill them in for time's sake. Okay, N, this is NP, which is 81.8 times 0.9. It's NP 1 minus P. Okay, so standard deviation is 8.58. So here's 81.8. And they ask, what's the probability that fewer than 100? Okay, so they want to know what's the probability that X, which is the number of bald men out of these 818, will be less than 100. Now remember, this is continuous. So this is the same thing as writing this. You don't go down to 99. It's the same. Okay, I'll leave it at that. Okay, so now let's go to our graph. And we want to go to 100. And it says probability that fewer than 100. So I draw my line here. Shade to the left. Shade to the left. So I need to turn that X into a Z. Okay, I need to standardize that. So my Z equals 100 minus 81.8. I'm finding out how many standard deviations it's away. Okay, so since I have this, I'll go ahead and store this to keep my numbers perfect. So I'm going to put this in the A. That's my standard deviation. Okay, so I have 100 minus 81.8, which is my average. And I find the difference, the absolute difference of that, and divide that by my standard deviation, which I stored in A, so I don't get round off error. I don't want round off error. So this would be 2.12. Okay, so I'm going to go ahead and store this in B. Store that in B. That's my Z-score. So I want to find out the probability that Z is less than 2.12. Okay, so now to do this, to find it, you could use your tables, but we didn't go over tables too much because we could do this on our calculator. So I want to the left, so I need to pick, really we're off here on the Z distribution, which is a 0, 2.12, sorry, 2.12, and I'm shading to the left. So we need to pick a small z over here. So second bars, normal CDF, pick a small, that's a z-score. It's a pretty big z-score, but I want to go all the way to negative 2.12. From there all the way over to here. Should be a rather big number. I put a negative there. It should be a big number, not a small number. So I must have hit something wrong. See, I already know I did something wrong here. If I go up here, go right here, something went wrong. See, I put a negative there, but it's not negative, it's positive. So it's a positive 2.12. So that's good. You guys could see mistakes and understand that this, I know, see this shaded region so big, I know it's going to be bigger than 50%. So as soon as I get 1.7%, I know I did something wrong. Okay, so it jumped on with, because I already started doing it over again. So it went on the same thing, the same line. So I'll just do it over again. 2.12. I already stored this number. I stored this in B, if you remember, so I could do alpha B. Okay, so it's going to be about a 98.90. So there's a 98.3 chance of having fewer than 100 men that are bald. Okay, So hopefully you see how that works. And you could check this to see, you could compare this to what you would do the other way. So the other way would be a binom, CDF, okay? And out of 818 men, they have a 10% chance, and in this case it's fewer than 100, so this is discrete, so you would have to go to 99, and that, and you could double check that to see what that is and see how close. Well, I'll do it. Second distribution, we want to go to binom CDF, enter, we want to say 8. Okay, so 97.8. So it's pretty close. This was 98.3%. This is 97.8%. So it's very, very close. Okay, let's do one more example, and then we'll be done. Okay, so a multiple choice test consists of 50 questions with 4 possible answers. So I have 50 trials, and the probability of success is 0.25. Okay, the question is this a binomial? Okay, so we'll say how many successes do we expect? Successes. This equals to NP, which would be 50 times this, which should be 12.5. I just do 5 times 25, which is 125, and there's the 2 decimals there, which would be that. Okay, so how many failures do we expect? How many failures? This is 1 times 1 minus p, okay, which should be 37.5. Okay, let me just double check just to make sure. Do the first one, and then I could just do the rest of them will be that, so that's just 50 minus that answer. Okay, got 37.5. So they're both greater than or equal to 10. So this is enough. So this is a big enough n to claim that the distribution of the binomial can be used as a normal. Now notice I'm putting NP 1 like notice that I'm doing this. I'm putting NP and then I'm doing NP 1 minus p. Why am I doing that? Because this is the mean and the standard deviation of a binomial. That's why I do that. Okay, so here we go. We have this. Okay, so what do I expect? What's the mean? The mean here is n times p, which is 12.5. What's the standard deviation? The standard deviation of x is equal to the square root of n times p times 1 minus p. So I'm going to do this the long way. N is 50, p is 0.25, and 1 minus p is the complement of 0.25, which would be 0.75. Okay, let's put my calculator in. So root okay, now when I get this, I'm going to go ahead and store it automatically. Just store it. Store this number, okay? Store this number so they don't get round off error. So I got my standard deviation in A. My standard deviation is in A. So now this should be 12.5. Okay? 50 questions. Out of 50, that's how many we expect to get right. So let's say, when I wrote this question, I thought I was saying half of them. I thought P was 0.5. So I was saying my number was a little higher. So let's say, what's the probability that they'll get, let's say, more than 18? More than 18 correct. Okay, more than 18 correct. So come over here to 18. So come over here. Here's 18. Scan up, and it's more than 18. So I need to find the shaded region right there. Okay. and this standard deviation over here, let me write this in, it's 3.06. Now we need to find this shaded region to the right, which will be the probability that my x, because these are all x's, x is the number correct out of 25, or out of 50 tries. 50 tries. So I want to know what's the probability somebody will get more or equal to than 18 correct. I need to turn this x into a z. So z equals the statistic we got minus the parameter of my model, which is 12.5, divided by the standard deviation, which is 3.06. Now notice I round there, but my real answer I don't round. Okay, so let's run this. Find the z-score. 18 minus 12.5. Enter. I stored my standard deviation in my A. Okay, I didn't hit divided by. So it's going to be 5.5. That's my absolute distance divided by A, which is in my standard deviation. So that's going to be 1.7963. Go ahead and store this right away. STO, put this in B. Okay, so now I standardized it. So I'm on the Z distribution. Okay, so 0, 1.79. Okay, so I'm going to pick this 1.79 and go pick somebody way over to the right. So this is going to be, let me just put this real quick. I'll just put 1.8. This is going to be normal CDF. And we want to have this number, 1.796. Don't round it as much as you can. And I want to go to a really big Z. So I'm on the other side now. Okay. So let's do that. Second vars. Now remember I stored my z-score into my B. So alpha apps, that's B. Now I want to pick a big number. Okay, so there's about a 3.6 chance that somebody will guess correctly. Okay, that somebody will guess correctly and get more than, or that will guess on a 50 questions and get more than 18 correct. Okay, so that's it. That's it on how to do that one. We could do it the other way, just to show you. Actually, I'll just give you the formula. If you're going to do it the other way, you do 1 minus binom CDF. We have 50 problems. There's a 25% chance, and we want to run this all the way to 17. That should be something very close to that. All right. Thanks for watching.